Okay, yeah, so this is the second time that I've done this talk. Hopefully it will be really interesting. I'm a big fan of graphs and graph databases. This really makes me excited, so I hope you enjoy it with me. Did I just turn off my clicker? I might have just turned my clicker off. There we go. Yeah, so this is me. I'm currently a student at Cov Uni. I enjoy Linux and FOSS stuff. I like really hard problems. I do not do web programming, so don't talk to me about JavaScript. Yeah, and as I said, I'm a big fan of graphs, and I like graph databases. So we'll start off with what a graph is. I'm not talking about bar charts. I'm not talking about some dots with some axes. I'm talking about nodes and relationships between those nodes. So on the screen here, we have a node which has my name in it, and we have a node which has Hackference in it. Both of those things are pieces of data. Connecting the two pieces of data is a relationship that says spoke at. Samathy spoke at Hackference. That will make sense. It's nice. How can we use graphs to describe things that are going on in our world? A big thing that we can use graphs for is social graphs. So there we have Mike is friends with Samathy, or at least I hope he is. So that's a small social graph there. Social graphs are all around us, things like Facebook, LinkedIn. They're all graph databases behind those that are linking nodes that represent people to other nodes that also represent people and the relationships that go between those. Physical world. Graphs can represent objects in the physical world, and they can represent places. Things like Google Maps has a lot of graph databasey stuff going on to represent places and how they're connected to other places and all that kind of stuff. But essentially, it's all about connected data. So it's not about storing your data and then storing some other data and you having to know that those are related to each other. With a graph database, you have the data in a node, and that the relationship between a node and other nodes is in itself a piece of useful data. So what is a graph database? Well, graph databases are quite simply a system kind of surrounding a connected graph that allows you to create, read, update, delete data in the graph. So that's nodes or relationships. Graph databases also provide systems for traversing the graph, for searching and understanding the graph that you're using. So it provides things like storage functionality, allowing you to load and save bits of the graph in a nice performant manner. A graph database does all the things you'd expect from a normal database, but it just operates on top of a graph instead of tables or documents or whatever else you might find. So why a graph database? Graph databases, because they are much faster for connected data, so we can utilize its full potential. So take the above two tables here. We have a table of items and a table of years. The table of items has got a jar and a pot in it. The table of years has got a couple of years in it. We know that because we're humans that those two things are probably connected in some way. However, this kind of data isn't described in our database at all. And when we do want to connect those pieces of data, we have to do some computation, and we have to do some code, some SQL, and connect the two things together to pull it out of the database or to put new things in. If we use a graph, we have a jar node, and we can just have a relationship from that jar node to the date node. And it's right there. The information that we need is right there, connected to each other. So if we want to know what things were created in 1803, we select 1803 and go, what relationships does this have going outwards that are of the made-in type? So it's very good. It's very fast. Yeah. Right. Yep. There we go. Flexibility is also a big factor in graph databases. They allow us to create our data as it happens without knowing what it will be connected to in the future and what information we might want to add and have in our nodes of data. The structure can grow with our understanding of the data set. It's flexible, it changes. We can add new relationships as we discover them. And it helps us get going when we know at least one thing about our data, but we don't know what else might happen, so we can just add it when we're ready to add it. And graphs also are very helpful in helping us visualize our graphs and working out, to us humans, what interesting things are connected to other interesting things. There's a nice interface that I'll show you later with the Neo4J graph database that allows you to explore a graph using queries, and it will show you the graph with all the connection nodes. And you can look at that and go, oh, these things are all connected to those things. Graphs are very insightful. They allow us to learn things that we might not have otherwise noticed previously. So when we look at our visualization of a graph, we can work out and notice stuff that maybe wasn't so clear when you just saw the data in tables. For example, this is a graph that has a couple of people in it and a couple of products. We've got Mario Kart, the video game, and Diet Coke, the beverage. And we have some data that says that Cristiano and Jess both enjoy Mario Kart and Diet Coke, and they've both bought those things. We also have a node that contains Mike in a ball. So from looking at this graph, we can go, wait a minute, Mike also bought Mario Kart. 2 other people also bought Mario Kart. It is quite possible that Mike might like Diet Coke. And being able to visualize a graph allows us to have these insights into information that we might not have noticed if it was just sitting in tables, not connected. Yeah. So I mentioned graph databases providing a CRUD interface above a graph. But if you've got that interface, you need to have some kind of way of controlling your graph, adding things, changing things. And those are querying languages. There's a few graph querying languages that are available and popular at the moment. The database that I'll be using today, Neo4J, they have their own proprietary language called Cypher. It's personally my favorite language, and I'll show you in a bit why I think it's so good. But there's a few others. GraphQL, which I'm sure a lot of you have heard of, is very popular at the moment. I believe it was developed or came from Facebook. It is supported by Neo4J, so you can use that on the Neo4J database. There's SparkQL, which is from the World Wide Web Consortium, and Tinkerpop, which is an Apache project. It's worth noting that although Cypher is proprietary and comes from Neo4j, there is a project supported by Neo4j called OpenCypher, which aims to allow other databases to support the Cypher querying language, which is really useful for other graph databases that are maybe open source, or other databases like MongoDB, which I think has a Cypher front end as well. So that's really nice if you want to use some other database to turn it into a graph database. So moving on to Cypher, as I said, one of my favorite languages, because not only is it a good graph database language, it's good because your queries look like graphs if you know what you're looking for. So this is a little graph that is a social graph. It links together myself, Cristiano, and Jess. But if you look at just the query, which describes the graph, Samathy is enclosed in curved brackets here, like in a circle, i.e. a node. The relationship between me and Jess is going that way, and that's the type of relationship that it is. The Jess node has a relationship to Cristiano, and then there's a comma because the relation, you're describing a new relationship below that, and that's the relationship that Cristiano has to me. So when you look at the query and the graph, you can quite easily tell roughly what the query is doing and how that might be represented as a visual graph. So some basic queries. We've got create query at the top, which creates a node that is me with my name, creates a relationship, a new node for Jess, and a new node for Cristiano with the relationship between that and Jess. We've then got a match query between A, which is just a variable that is a node, and S, which is another variable that is a node. So this query will match two nodes where the name property of the S variable is Samathy. So the return from that will be any nodes, including myself, that have a relationship to the node for me. And then we can perform a delete query where we need to select the node that we want to delete by matching it, and then we delete it. It's important to note that you can't delete nodes that have relationships. You have to delete all the relationships that it has before you delete the node, because otherwise you'd end up with hanging relationships that aren't attached to anything, which is not a very good thing at all. So I'm going to skip this live coding because the one at the end is quite a bit more interesting. How much time do I have left?
23 minutes.
Oh my goodness. I think I've been talking very, very quickly. So, where is Neo4J used in the real world? Something that you might have heard of, the Panama Papers, which happened a couple of years ago now. A massive thing, really big thing in the news. They had lots and lots of documents which all got scanned and then analyzed, and all of the data inside those documents was placed into a Neo4j graph database, and the journalists used Neo4j to connect different things in the documents to each other, and then learn about the data and how it's all connected with the graph. So by visualizing the graph, they noticed that things were connected, that maybe was an interesting point, and not directly connected either. So people were connected by other people. There's another thing called the BuzzFeed Trump World dataset, which is a bit more recent, which was essentially a graph of everything that Donald Trump is connected to, which, again, is the same sort of interesting thing where they put a lot of data into a graph database and visualized it and went, wait a minute, Donald Trump is connected to a whole bunch of stuff. But in practical companies, we have eBay. eBay use graph databases to support their recommendations platforms because, as we saw earlier, you can go, there's a few people who have bought this thing, there's one person who's bought that thing. What else might they want based on the connections that they have to items that they've already purchased? Medium and Walmart do very similar things to eBay. They recommend products and articles in the case of Medium by doing the same thing. This person read these stuff, that person read the other things. How are they connected? What things might people be interested in the future? And LinkedIn use graph databases in their social networks, and they actually provide on the little right-hand side, they often have suggestions and how you link to other people. And they say, oh, you've got 91 connections. You might be interested in this company because 10 of your connections are also connected to this company via everyone else. And all of that is through insights using graph databases. So Neo4j, that's what I'm going to show you today with a bit of live coding stuff. You can get the community edition, which is free from neo4j.com/downloads. And you can also pick up a digital copy of the graph databases book, which, like this talk, uses Neo4j as the platform to describe things. But it is genuinely very good if you want to learn about graph databases, how you can use them, and what they're good at. So the third example, I'm completely off with the numbers there, Hackference talks. So let's have a bit of fun. with some graphs. Right. Where's my mouse gone? There it is, maybe? Yeah. Cool. So, I'm going to start by creating a node in my graph for this particular talk. So, we're going to create a node which is of the type talk, and we're going to give it the title we want to make that caps. Have I got a typo somewhere?
It looked like a single quote, but I think it is a double quote. It's just the screen not showing.
Let's just type it again to make sure.
Yeah, it's just
Tell me if it's wrong. Okay. It's a little bit small. The resolution of this screen is also a bit odd. But as you can see, I created one node. It is of the type talk, and its name, it has a title attribute that says an adventure in graphs. So now I'm going to put that talk and add a relationship from that node to what time that talk is on. So first I'm going to match two nodes, one of them being of the type talk and the other one being of the type time, which I added earlier, with a where clause. And the name of the talk. And then I can match the time as well. Oh, I should mention that Neo4J is pretty flexible with types as well. So you can easily convert text into numbers and numbers into text, and you can do computations inside your query. So I've selected T, which is my talk. And I want to add the relationship going from T towards I, which is the time. And that's a create clause, so that's something that I want to make. There we go. So I created one relationship, and it was pretty quick. So I'm going to do something very similar, but this time I'm going to create a relationship between myself and the talk. And that's T.
Is it meant to be a match at the start?
Oh, it is. Well spotted. Yeah, so at the start, yeah, we're matching T of type talk and P of type person, where the name is Samathy and the talk title is An Adventure in Graphs. And then we're creating the relationship there. Just to let you know, you can also search for relationships. So if I add a variable there, R, onto the relationship, then I can return that variable. And that also works with match queries as well. So if you're, oh dear, did I get something wrong? I might have got something wrong. No. Live coding is always fun. You're never sure if it's going to work. Let's try that and see if that works. Did I add my surname? Oh dear. So this is why I left loads of time there, so that I could get it wrong. Oh, well spotted. It might be. So this is the web interface, and you can see that I can actually see the node labels on that side, which is really useful for things like that. There we go. Yay! Well spotted, whoever helped me out with that. Yeah, so I can do. I've got loads of time, I think. So I'm gonna go ahead and match my person to the conference. Yep, so this is a relationship from me, and it's saying that I am speaking at Hackference. I am. I can't see what I'm doing on this screen, by the way, so I'm just typing blindly, hoping that it's right. One relationship created in 5 milliseconds. Very good. I've created a bunch of relationships between nodes, and now I can show you what the whole graph looks like. So let's see if this works and we get the whole graph. Nope. Nope, just got an extra comma and I'm missing a bracket. Nope, nothing. What am I missing?
The relationship is delivered.
Delivered? It's definitely delivering.
No, you have delivered as well.
Oh, and I did the person wrong again. It's probably that one. There we go. So let's make that full screen so you can all have a look. So this is a graph of all the people, the times, and the talks going on at Hackference today. As you can see, we can make some insights into this, and we can see that there are, in some cases, more than one talk happening at more than one at the same time. But all of the talks are happening at Hackference, so that's quite interesting. How much time do I have for questions? 10 minutes. So we've got 10 minutes for questions. I'll try to answer them best I can. If you want to ask some questions, that would be cool. Don't think there's any more slides. It's just that one. Yep, so just questions at the front.
How do you, like day to day, how do you deal with different tenses of words? So like delivering or delivered, like is there standards behind that, or is it depend on what you do?
Yeah, there isn't any standards. I definitely see what you mean. It's hard. I suppose it's just something you have to come up with within your own business and go, we are always going to use the past tense or the present tense or the future tense and just work it out. But yeah, there are no standards. Yeah, it can be whatever you want. Yeah.
How do you manage Schema Revolution, so you know what's in your graph, like what to ask for? Like, if you had a set of tables, you have foreign key relationships, so you know what you can join to what.
Yep.
And how does
Yep. So I mentioned relationships actually being data. So you can also query relationships on nodes and see what nodes have what kinds of relationships and what type of node that ends in. But relationships have their own type. So I see what you mean. In some ways, you don't necessarily know what data you have in your graph unless you know what you don't know unless you already know. But you can query it to find out what is in there and how it connects. So, Terry.
Is there well, it was a great presentation. I've learned so much. But is there a way to quantify relationships? So, you might say on Facebook, I am friends with you and I'm friends with Cristiano, but I might be better friends with Cristiano than I am with you. Or, yes, because I love his shiny head. So can you say, so you said in the relationship is friends with or has bought, can you also put values on that? So if you want to say has bought 10 things or is super best friend?
So the relationships syntax has exactly the same syntax as a node. So you noticed I was doing curly brackets, title, name, whatever. You can do that with relationships and add arbitrary data to your relationship as well as the relationship type. So you could add a ranking or likes shiny heads.
And then presumably you could search or
yeah. So you can so you could match between two nodes with a type of relationship, but only if that type of relationship has this data.
Brilliant, thank you.
Can you
Go for it.
Can you first of all, when you type that in, can you make the relationships up on the fly? So you basically type in, and you've got a node, and you go, oh, wait a minute, I want to connect that.
Yep.
You don't have to pre-program those sort of relationships.
No, it's entirely whenever you feel like it. The create operations, as long as you have two nodes that you have previously matched, so then you can create any relationship in between them at any time.
Right. And the other sort of corollary to that was, can you set it up so that, for instance, I was thinking about like a family history database, so you do like a family tree. So you have a relationship where if A is the parent of B and A is also the parent of C, that will automatically make A and B and C siblings. A and C siblings, you know what I mean?
I suppose that's something you'd have to do at a high level. The database won't do that for you.
Okay.
Our databases do.
Are they?
Yes. There's one called Graphing, which is a graph knowledge database, which does.
Cool.
So that's kind of inference where you infer from the data what you have, what data is missing. Well, that was actually my question about the Neo4J. So first of all, why is it called Neo4J?
No idea.
No idea.
The developer is Swedish, so.
Okay. You were talking before about like, if two people bought these products and one person bought a third, one of the products, he might also like that second product. Again, that's kind of going back to the question that was raised before, that would require you to kind of look at the graph and as a human kind of make that assumption. Is there tooling to kind of like infer these kind of relationships out there?
I think there's definitely tooling to do that, but as I said, the database does not do that for you. So you have to do that on top. But there is stuff within the querying language with things like shortest path, and so it will do all of this graph traversing for you. And you can definitely do things like select all of the nodes that have relationships to this other node and that kind of stuff. So you can quite easily build tools that will do that inference for you.
Typically, do these kinds of graphs scale better with larger amounts of data than, say, more traditional table-style databases?
Yep, so to ruin a quote, it's graphs all the way down. So Neo4J, in memory, it's graphs. On disk, it's graphs. Distributed is graphs. So it does scale very well because they do a lot of intelligent splitting up of different pieces of graphs that aren't necessarily connected at the moment, or moving things around once they get connected and that kind of stuff. Let's have John at the back.
Are there any like org-style client libraries that would like let you kind of build queries in a more fluid manner and potentially stop things like plain text injection attacks into your query language? Since it all seems fairly kind of SQL text-based kind of thing.
There is I can't remember what it's actually. It's called Bolt. There is a proprietary binary protocol. There is a binary protocol that all of the first-party driver libraries for various different languages support, so that you're not just sending text. And most of these libraries, as well as supporting you to write Cypher queries or any of the other supported query languages, they all do things. What's the word it begins with an I? In the way that in the style that the language does it. So idiomatic, in an idiomatic way. So I don't know, for example, in Python you can create an object, and it will do something. It has a method to match this, and you pass it an argument. So yeah, Cypher is just one of the ways to query the database. Yeah.
It seems, I know nothing about graph databases, but it seems like nodes and relationships, from what you said, both have time, both can store arbitrary data.
Mm-hmm.
What can either one do that the other one can't? Or is it just arbitrary for reasoning about a query that we call one type of node relationship and the other one cannot?
Relationships have directions.
Right.
Nodes do not have directions. Relationships store. So one thing can be connected to another but only one way, or both ways, or the other way.
That's the network part.
Yeah.
So that's
So do you think that a graph database is useful as like an operational store, or is it mainly, have you mainly used them as like a projection of some other source of truth?
I don't know of any people that use them as, well, I suppose there are lots of people that use them as their actual back-end database, like eBay or LinkedIn or whatever. But I'm not really sure. I might not be understanding the question. Can you try and explain it a bit better?
Yeah, so like you may put most of your data into a relational store,
right,
and then when you've got specific questions that fit the graph database, project that into a graph database, or you may just chuck it into a graph database in the first place.
Yeah, you can definitely chuck everything into a graph database. Neo4J supports direct importing from relational databases and turning it into a graph. And you can turn relational databases into graphs fairly easily. So it's not. One of their taglines is "Everything's a graph" if you think about it in the right way. So yeah, you can use it for everything essentially if that's what you want to try and do. Are we up?
Yeah, we're done.
Wonderful.
Everybody give a big round of applause.
Thank you very much.